Good day, students and viewers. In this video, we are going to look at the 6 trigonometrical ratios of each of the following angles: 30 degrees, 60 degrees, and 45 degrees. Now, for A and B, which is 30 and 60 degrees, we first draw a right angle triangle, an equilateral triangle. So we draw an equilateral triangle of length, say 1, 1, 1. So you see, in each of the angles here, each angle is 60 degrees, 60 degrees, 60 degrees, because the three sides are equal, and so the three angles must be equal. So which is equals to 60 plus 60 plus 60 will give the sum of angles in a triangle, which is equals to 180 degrees. Now we draw a perpendicular bisector. It will bisect this angle into two. So 60 divided by 2 here will be 30 degrees. Here will also be 30 degrees. But this line, the length here is 1. So when we divide it into two equal halves, so we're going to have 1 over 2, 1 over 2, and that's half half. Now this is a right angle triangle, so triangle A, B, C. So you see, and let's call here M. So triangle AMC is a right angle triangle on its own. We have another similar triangle, MBC. So you can use either of the two to find the ratios of the trigonometrical ratios of 30 and 60 degrees. Now here is 60 degrees. Here is also 60 degrees, as we have mentioned earlier. But this length, we don't know, line MC. But all we know is that this is a right angle triangle, so, and the length here is 1. So therefore the length 1, so it will be 1 square, that's the hypotenuse, is equals to this side, square it. So you have, let's call it MC. The line MC is a line segment, plus the size of this line, we square it, plus that is equals to 1 over 2 when we square it. So it means when we bring 1 over 2 here, we have line MC square is equals to 1 square minus 1 over 2 squared. This is equals to 1 squared minus 1 over 4, because when we square it, we have 1 times 1, 2 times 2, so we have 1 over 4. But this is equals to 1 minus 1 over 4, because 1 square is 1, so we have 4 over 4 is the same thing as 1, minus 1 over 4. So now common denominator 4. So we will just say 4 minus 1, and that is equals to 3 over 4. But MC square is 3 over 4. So this is the same thing as MC all squared is the same thing as 3 over 4. Now what is MC? We take the square root of both sides, so that the square root of MC squares and square root will go. This is equal to the square root of 3 over 4. We don't have at hand the square root of 3, so we just write root 3. And then when we take the square root of 4, the answer is 2. So line MC is the same thing as root 3 over 2. So we have, and so we have sine 30 degrees. Let's start with 30. This is equals to sine. So this is opposite to 30. Opposite to 30 is AM. I'm using triangle AMC. So opposite to 30 is AM. But AM is of size 1 over 2. Opposite divided by hypotenuse, which is equals to 1. So half divided by 1 is the same thing as half. So sine 30 is equals to half. So we see cos 30 degrees is equals to adjacent over, so the adjacent here is MC, which is equals to root 3 over 2. So square root of 3 over 2 divided by hypotenuse, which is equals to 1. And that's equals to square root of 3 over 2. So remember, adjacent to 30 is this, because 30 is lying on the line MC. But adjacent to 60 is line AM. Always remember the two distinctions. Now, tan 30 degrees. So tan 30 is equals to, well, I'm talking in respect to 30 degrees. So tan is opposite over adjacent. What is opposite? 1 over 2. What is adjacent? Divided by the adjacent is root 3 over 2. Square root of 3 over 2. But this is equals to, so we say this is equals to 1 over 2 times 2 over root 3. Because when we change this symbol division to multiplication, we take the reciprocal. And so the 2 will cancel. And so we have 1 over the square root of 3. That is equals to tan 30. Now, what is the cot? What about the cosec? Cosec 30 degrees. This is equals to 2 over 1, which is equals to 2. What about the sec? Sec 30 degrees is equals to 2 over root 3. What about cot 30 degrees? This is equals to root 3 over 1, which is equals to square root of 3. Now, let's talk about the 60 degrees now. Angle 60. So, in terms of 60, we just stop like this. So, sine 60 is equals to opposite to 60 is line MC over hypotenuse, which is line AC. So line MC is given as square root of 3 over 2 divided by 1, which is equals to square root of 3 over 2, because any number divided by 1 is that number. So we have cos 60 degrees. This is equals to cos is adjacent over hypotenuse, and adjacent is 1 over 2 divided by hypotenuse, which is equals to 1. And so the answer is equals to 1 over 2, which is 0.5 normally in when calculator is used or any computing device. Now we have tan 60. This is equals to, the tan is opposite over adjacent. This is equals to square root of 3 over 2, because this is the opposite. Let me write root 3 over 2 here for easy identification, divided by adjacent, which is equals to 1 over 2. But this is equals to root 3 over 2 times 2 over 1. So 2 cancel 2. And what do we have? So we have root 3. So that is it. Root 3 over 1, which is equals to square root of 3. Now, the other three trigonometrical functions for 60 degrees. Now we have cosec 60 degrees. This is equals to 2 over square root of 3. And we have sec for cosine 60 degrees is equals to 2 over 1, which is equals to 2 over 1, and that is equals to 2. Now we have cot 60 degrees. This is equals to, for the cot, we have 1 over root 3. And that is it for 30 degrees and 60 degrees. Now let's talk about angle 45 degrees. Angle 45 degrees, which is now C. We have answered A and B, and we want to find angle 45 degrees. Now 45 degrees, ratios of 45 degrees. So we draw a right angle triangle, in fact an isosceles triangle, because you cannot make this angle 45 until here is 45, so that here is 90 degrees because it's a right angle, and you know 45 plus 45 is 90. So 90 plus 90, you have 180. That's the total sum of angles in a triangle. But now let's make this side a unit and this side a unit, because the two base angles are equal, and so the sides, their corresponding sides, must be equal. So this is 90 degrees. Now, but we don't know what this side is all about, the hypotenuse. Call this A, B, C. Now we are looking for line BC. Let's call it X for easy calculation. Now, X squared, by Pythagoras theorem, the square of this is equals to the sum of the two squares. This is equals to 1 square plus 1 square. But X square is equals to 1 plus 1. X square is equals to 2. Take the square root of both sides, you have X is equals to what? Square root of 2. Now, this is square root of 2. So, whenever you are talking about the length of line AC, is square root of 2. Now, sine 45 degrees. This is equals to opposite over hypotenuse. That's equals to 1 over square root of 2. Now, cos 45 degrees. But this is equals to adjacent over hypotenuse. And that's also 1 over the square root of 2. Tan 45 degrees. Opposite over adjacent, which is equals to 1 divided by 1, and the answer is 1. Now the other three corresponding trigonometrical functions, like the cosec 45 degrees, is just the square root of 2 over 1, and that is the square root of 2. Now we talk about the sec in place of cosine. Sec 45 degrees, and that is equals to 2 root 2 over 1, and that is equals to root 2. The same. Now tan, for tan, you just say cosine over sine over cosine, or you just use this reciprocal. But for just an interest, let's try this. So tan 45 degrees is equals to sine 45 degrees over cos 45 degrees. But what is tan 45 degrees? What is sine 45? 1 over square root of 2 divided by, what is cos? Is 1 over square root of 2. But we can say 1 over square root of 2 times, we take the reciprocal, root 2 divided by 1. So 2 will cancel root 2, and so we have 1 divided by 1, and the answer is 1. Thank you very much for watching.